Okay guys, so we are going to take a look at simplifying radicals. Okay, so first thing we're going to look at this. That is called a root. You pronounce that root. It's a square root, okay, as long as there's no number there. If there's no number there, it's understood to be a 2. This is equal to this. But again, when there's no number there, it's just understood to be a square root, so you don't see that very often, okay? And if they said this, they would say root 25, and they would say, what number, what's the positive square root of 25? And the answer to that is 5. That's because 5 is called a perfect square. So over here, I'm going to make a list of the perfect squares. You don't have to memorize this list. You can create this list anytime you want by saying 1 squared, 2 squared, 3 squared, and go on. So 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and 4 squared is 16, and then it's 25, and 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. You could keep going, but that's going to contain most of the problems that we do. Okay? Now, like I said, if you have a perfect square, it's easy. Square root of 36 is 6. Okay? Now, the first thing we're doing with these simplifying square roots is we're really not going to simplify. We're going to talk about estimating them in case you see that in the MCAS test, which happens frequently. I don't know if there'll be an MCAS this year. Okay? But we're going to talk about estimating radicals. So if I had the square root of, say, 22, all right? Now, I know the square root of 25 is 5, and the square root of 16 is 4. So I know that this is going to be approximately 4 point something, because it's bigger than 4, but it's less than 5. Now, 22 is here. It's, what, 6 away from there, and it's 3 away from there. So, it's not going to be 4.5. It's going to be bigger than 4.5. So, I don't know, you kind of look at it and you try to make your best guess. I'm going to say maybe 4.62 or something, okay, because I know it's a little bit bigger than 4.5. And I'm going to type it in my calculator, and my calculator tells me it's 4.69. So that's a very, very good estimate, okay? Let's say I had this. The square root of 38. Let's see where 38 comes on my list. 38's right here. Okay? 38 is only 2 away from 36, and it's 9 away from there. So it's really close to 6. So I'm going to say it's going to be 6 point something. And then, again, you just kind of do your best in terms of what you think it's going to be. You probably want to say like 6.1 something, or maybe 6.2 something. Let's say 6.18. We'll see how close we come. The correct answer is 6.16. So again, that is a good estimate. So let me put out a couple for you. Let me put out 110, and let me put out the square root of 11. So I want you to pause the video, take a look at that list of perfect squares, and make a guess. As long as you're within 1/10 or 2/10, excuse me, it's a good estimate. It doesn't have to be exact. So pause the video and give that a shot. Okay, so we're back. 110 is between these two. It's 10 away from here, it's 11 away from there. We're never going to get one that's right 4.50 or 10.50 or 11.50, but we'll get really close to that. So for this one, it's bigger than 10 because the square root of 100 is 10, but it's less than 11 because the square root of 11, square root of 121 is 11, so I'm going to say it's 10 point something. Now, it's 10 away and then it's 11 away, so it's really close to the middle. So maybe I'll say 10.48. And we'll see how close we came. Hold on, let me type that into the calculator. 10.488, so it's 10.49. Very good estimate. Square root of 11. Square root of 11 comes in here. So it's close to 9. It's not that close to 16. So we're probably going to say this is going to be 3.23. That's my guess. 3.23. Come on, I got to get one of these things close. 3.32. But still a good estimate, okay? So that's how you estimate. Now, when they ask you to simplify, again, these are just estimates. When I type into the calculator, that's an estimate. It's a rounded answer. It's not an exact answer. Let's say I had simplify and I had the square root of 8. So what we have to do is we have to look at our list of perfect squares and see if there are any numbers on my list that divide evenly into 8. If you have a choice, you want to pick the biggest one. So when I look at that list, I see the number 4. So I'm going to make this into the square root of 4 times the square root of 2. Because there's a property that says if you have the square root of AB, I can write that as the square root of A times the square root of B. So that's kind of what I did here. I took 8 and I wrote it as a multiplication problem of 2 of its factors. However, I know what the square root of 4 is. The square root of 4 is 2. So I can rewrite that as 2 root 2, or 2 square roots of 2. Okay? Let's say I had this one, square root of 40. Look for a number on that list of perfect squares. A number on this list that goes into 40 evenly. 40 is a composite number. It seems like there'd be more than one number on the list, but really there's just one, and that's 4. So I'm going to make this the square root of 4 times the square root of 10. Now the square root of 4 is 2, so my answer is going to be 2 root 10. Okay? Again, I'll put that list of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and 196. So let's look at some more. Let's say I had the square root of 90 and I had the square root of, I don't know, 50. So I want you to take a look at those two and see how you can simplify them. Pause the video and give them a shot. So hopefully you're back. Let's take a look. Perfect square that goes into 90. That's going to be the square root of 9 times the square root of 10. And the square root of 9 is 3, so we're going to make this 3 root 10. And then the square root of 50. That's going to be the square root of 25 times the square root of 2. And the square root of 25 is 5, so I get 5 root 2. Okay? I want you guys to try this one. Okay? Give that one a shot. Please pause the video. Give it a shot, and we're going to talk about it. I think I'm going to catch you guys on this one. Okay? I think I'm going to catch you. All right, let's see. So, I want to know how many of you guys picked 9 and 8. And then you did the square root of 9 is 3, and you made your answer 3 root 8. You can raise your hand. I can't see you. Okay? I can't see you, so you can raise your hand and I'll never know. I'll never know if you did that. But I know some of you did. Now, that's not the answer I'm looking for. For this one, the 8, I can make that root 4 root 2 like we did on the previous page. So I'm going to make this 3 root 4 root 2. The square root of 4 is 2, and 3 times 2 is 6, so we get 6 root 2. Okay, now, there's a faster way to do that. At the beginning of this video, I told you that if you have a choice between numbers to pick, you want to pick the number that is the larger of the two numbers. If there's 2 perfect squares that divide evenly into that number, you want to pick the bigger of the 2. So when I look at this, I can make this 36 and 2. Okay, now the square root of 36 is 6, so I get 6 root 2. So I get to the answer a lot faster. It's kind of like when you have fractions, okay? And if I had 30 over 60 and I said reduce that, and someone said, okay, I'm going to divide it by 2. And you can do that, but then you get this. And then they're going to say, okay, I'm going to divide by 5. You can do that. And then you get this. And then you say, well, now I have to divide by 3. Okay? Or you could have taken that 30 over 60 and you could have divided by 30 right away and got to that same answer of 1/2. So it's okay to do it this way. You just have to do more steps. If you pick the largest perfect square that goes in, you're going to have fewer steps like that. Okay? So looking at that, I want you guys to try this one and see what you can do. Well, the biggest perfect square that goes into that is going to be the square root of 16. So I'm going to make that the square root of 16, the square root of 3. The square root of 16 is 4, so I'm going to get 4 root 3. Okay? Let's say we had some letters. We haven't done any with letters yet. So now we have to look at each base separately. 24 is a base, y is a base, and z is a base. So I make my 2 square root signs, and I look at 24 first. What is the only perfect square factor, or the biggest I should say, because there's 2, perfect square factor of 24, and that's going to be 4 times 6. Technically 1 is a perfect square factor of 24, but if I use 1, I don't get anywhere. I have 1 and 24 and I'm back where I started. Now y to the 5th, is that a perfect square? Can I multiply something times itself and get y to the 5th? And the answer to that is no. Okay, you need an even exponent to be a perfect square. But I can make this y to the 4th times y, because y to the 4th is a perfect square, and it's the biggest perfect square that divides evenly into y to the 5th. Is z squared a perfect square? Is z squared an even exponent? Because if it's an even exponent, it's a perfect square. So I'm going to put my z squared over there. The square root of 4 is 2. The square root of y to the 4th is y squared. And then the square root of z squared is z times the square root of 6y. Okay, so that's how you do those. Let's look at a couple more like that. Okay, the square root of 18, x to the 7th, y to the 6th, and z to the 5th. So you make your 2 perfect square signs. Now I look at 18. What's a perfect square factor that goes into 18? Well, that's 9 times 2. For x to the 7th, what's the biggest perfect square that goes into x to the 7th? That's going to be x to the 6th times x. And then I ask myself, is y to the 6th a perfect square? And the answer to that is yes, because it's an even exponent. So I make it y to the 6th over here, and I don't put anything over there. And then z to the 5th, 5 is odd, so that's not a perfect square. So I'd have to make it z to the 4th times 1 left over z. Okay? So when I look at this, I need to find the square root of that stuff. I'm going to say the square root of 9 is 3. The square root of x to the 6th is x cubed. The square root of y to the 6th is y cubed. And the square root of z to the 4th is z squared. And I then multiply that times the square root of 2xz. Okay? So we do have a sheet with these that we're going to practice, but I do want you to try one of these on your own before we go to that sheet. Okay? So I want you to try this one. The square root of 200, a to the 6th, b squared, and then c. See if you can do that one. Work your magic for me, would you? Pause the video. Pause that video. Okay, so perfect square part, leftover part. I look at 200, and I make it 100 times 2. A to the 6th, perfect square. B squared, perfect square. C, not a perfect square, and it doesn't have any perfect square factors because that's just c to the 1st, so I put it with my leftover part. Perfect square part, leftover part. Square root of 100 is 10. The square root of a to the 6th is a cubed. The square root of b squared is b times root 2c. Okay? So, I'm confident that that's enough for you guys to get started. Okay? So I want you guys, you know what, before we start that next video, let's look at this. This is a very famous, whoops, spelled it wrong, very famous theorem. It's called the Pythagorean Theorem, and it's in math all over. Okay, it's in all kinds of math classes. You'll have it in every math class after this, with the exception of statistics. And what it does is it relates the sides of a triangle in a right triangle. When you have a right triangle, you have one side that's longer than the other two, and that's called the hypotenuse. And that is opposite your right angle. The other two sides are just called legs. It doesn't matter which one you label as A or B, but C matters. It has to be that longest side. It has to be the side opposite the right angle. Now the theorem says a squared plus b squared equals c squared. So we're going to do two problems like this. Okay, the first problem is going to come out even when a is 2 and b I don't know, and c is, a is 3, b I don't know, and c is 5. And then we're going to do one that doesn't come out even when a is 4 and b is 5 and I don't know what c is. Okay, so I'm going to show you how to do these. All we do is we take that and plug it into my formula. So I've got a squared, so that's going to be 3. So I make it 3 squared plus, I don't know b, so I make that b squared equals c squared, which is 5 squared. 3 squared is 9 plus b squared equals 5 squared, which is 25. Well, we'll do to solve the equation. Minus 9, b squared equals 16, square root. B is 4. Technically, in an equation like this, your answer is plus or minus 4, but one of these sides can never have a negative measure, so b equals 4. So this one won't come out even. I'm running out of room here. 4 squared plus 5 squared equals c squared. 4 squared is 16, and 5 squared is 25, and that's equal to c squared. So c squared equals 41, and then I take the square root of both sides, and c equals the square root of 41. And that's it. You can leave it like that. Alright, so there's probably going to be a sheet for you to practice on these, and there'll be a sheet for you to practice on those up there. So do your best. If you have questions, send me an email. I think it's a pretty good explanation, and it should be enough for you to get some of those. Sometimes it takes more than one shot at these, so we may have to spend a little bit more time on this, and that's okay. Like I said, if you have any questions, send me an email.